Today, permutations. So what is a permutation? A permutation in this context, there are other meanings of the word permutation in mathematics, but in this context, a permutation is an ordered list of k distinct objects chosen from n options. And there is a theorem. We're going to jump right into the theorem about permutations. If you want to say how many ways can I do this, how many ways can I pick k objects with order, right? They're permutations from n options. Well, there's a special notation for that, which is this symbol here, this npk, right? If you see that written, that means permutations of k objects selected from n options. And I have a formula for it, right? You multiply together n times n minus 1 times n minus 2. And when you see something like that, you might think about factorials. Hey, that looks like a factorial. It's a lot like a factorial. It just doesn't necessarily make it all the way down to 1, right? So that's what we're showing here. It stops at n minus k plus 1. So that's why it's equivalent to this formula. That bottom factorial cancels out the extra factors that aren't there in in that top expression, right? That's sort of the missing parts of the factorial up there. So this is our definition. This is a theorem regarding that definition. Let's see all of this in an example, right? So let's see how this all looks in a very small concrete case where we can list everything out, right? So let's say we have we have 4 albums in a car for a road trip, right? And let's say we're on a Beatles kick, right? And on our road trip, we're driving through the middle of Utah on I-70. There are no radio stations whatsoever, no cell phone service, right? All we have is our CDs, right, in our car. And let's say we're on a Beatles kick, right? And let's say we have Let It Be, we have Abbey Road, we have Sgt. Pepper, and let's say we have Revolver, right? So these are the 4 albums that we have in our car. Sorry, Magical Mystery Tour, no disrespect, I love that album, but here's our White Album. Maybe we should try to Revolver for White Album. It's too late. We've gone too far. We've already written these out. So these are the 4 albums in our car, right? And but let's say we're on our road trip, and like I said, we're driving across this super desolate part of Utah here, right? And I know that stretch there in Utah, this stretch of I-70, I know that, let's say the stretch without any radio, without any phone service, right? This is, let's say this is 3 albums long, right? Of no music except CDs, right? And I want to know how many different ways can we pick the CDs? How many ways can we do DJ for ourselves, right? For that part of, how many music options are there for that part of the road trip, right? And we'll say no repeats, right? Once we listen to the album start to finish, but then we don't just play that album again, rather than listening twice in a row, we always change the CD up, right? So so in a case like this, what would this be? This would be exactly 4p3, right? Because I have 4 albums I'm choosing from, right? From our 4 albums, we're going to, from our 4 albums, right? We're going to pick 3, right? And the order matters because it's certainly different music experience, right? If we go Let It Be, then Abbey Road, then Sgt. Pepper, right? Versus if we first listen to Abbey Road, then Sgt. Pepper, then Let It Be. It's the same 3 albums, but we DJ'd just differently for ourselves, right? So this is our scenario, right? Also, we said no repeats, right? So this is what makes it permutation of 3 chosen from 4, right? So this would be by this formula. If I just blindly follow the formula, what would I have? Well, this formula tells me to do 4 times 3 times 2. That's the That's what the formula says, right? Because here I have, notice I have n equals 4. So I'm just gonna show how to use this formula, right? So right here I have n equals 4. So that's why I start here at n equals 4. That's the first part of this formula right here. Start at n, and then multiply 1 by 1 less, multiply by 1 less, and keep going until you get to what? You want to stop at n minus k plus 1. What was k in this case? K was 3, right? So when do I stop? Well, I stop at n minus k plus 1, which in this case is 4 minus 3 plus 1 is 2. So when you hit 2, then you stop. Right? That's how and in between, what did I do? I just multiplied by 1 less, right? And I stopped when I hit n minus k plus 1. Now, what is another way to think of this? Another way to think of this formula, this is maybe a little more natural, is this product will always have exactly k factors. If you sort of just count across, right, you can think of this last one as n minus k minus 1. And you can think of this first one as n minus 0. So it's, if you look at the number that's being subtracted from n, right, you're subtracting 0, 1, 2, 3, right, up to k minus 1. But there aren't k minus 1 factors because there's one extra factor for 0, right? So 0 through k minus 1 is a total of k factors. So that's one way you can think of how many factors there are. So you could also, when you're writing this, you could also think of, okay, I just do this process where I multiply by 1 less each time, but here I had k equals 3 factors, right? So lots of ways of looking at the same formula. Now here, what do I end up with? I end up with 24, right? This is 24 options. 24 ways I can DJ for myself in this case, right? Now, what is going, so here I just sort of blindly implemented the formula, right? Also notice I implemented the top formula. If you do the bottom formula, you get exactly the same thing, right? If you do, this is also 4 factorial over 4 minus 3 factorial, right? Which is 4 factorial over 1 factorial, right? Which also is 24. So that's another way to calculate this. Both are valid. Now, why? Why does this work? Well, think of, it's very similar to when we were drawing the tree diagrams for our fundamental principle of counting. You can basically do the same thing here. Think of the first album, right? The first album, well, I have 4 options for choosing my first album. I could choose Let It Be, I could choose Abbey Road, I could choose Sgt. Pepper, or I could choose Revolver, right? Now, regardless of which of those I pick, when I go to do my second album, I now have 3 options, right? If I chose Let It Be, I'm not allowed to choose Let It Be anymore, but I have exactly 3 options because I could choose Abbey Road, Sgt. Pepper, or Revolver, right? From Abbey Road's choice, I could choose Let It Be, Sgt. Pepper, or Revolver. From Sgt. Pepper, I could choose Let It Be, Abbey Road, or Revolver. And from Revolver, I could choose Let It Be, right, Abbey Road, or Sgt. Pepper, right? So there's my first album choice and my second album choice. Now, my third album choice, what's going to happen on this one? On my third album choice, I'm going to have 2 options for each of these, right? If I already picked Let It Be and Abbey Road, now I'm down to Sgt. Pepper or Revolver. If I already picked Let It Be and Sgt. Pepper, now I'm down to Abbey Road or Revolver, right? If I already picked Let It Be and Revolver, then I'm now down to Abbey Road or, oh, not what I picked, Abbey Road or Sgt. Pepper, right? And so on, right? I can keep 1, 2, 1, 2, 1, 2, 1, 2, right? I can keep doing that for all of these, right? So what happened? Well, this tree diagram has 4 times 3 times 2 equals 24 total options, right? By just seeing how they go across the tree, right? Each of these corresponds to one DJ option, right? So let it be, then Abbey Road, then Sergeant Pepper. That's one way we could have gone, right? If you go root to tree, you get one of the outcomes, right? So that would be an example here of a permutation, right? Of 3 albums selected from 4. Notice here, what's reducing the number of options each time is the fact that no repeats are allowed, right? I would have 4 options, 4 options, 4 options if I was allowed to repeat records, right? And then that would just be fundamental principle of counting. You'd have 4 times 4 times 4, right? So that's a one thing to notice. Also notice the fact that order matters. For example, if here, let me write out these 2. So if I did Abbey Road, let it be, and then from here I have either Sergeant Pepper or Revolver, right? So here, notice I really am counting, say, this gray DJ option, right? So this is Let It Be followed by Abbey Road, followed by Sergeant Pepper. I'm counting that as a distinct DJ option from Abbey Road, followed by Let It Be, followed by Sergeant Pepper. Right, I'm counting these as 2 different options: Abbey Road, Let It Be, Sergeant Pepper. Right, so notice these are distinct, even though they're the same 3 albums. Right, this is what I mean by order matters. Right, so in this case, order matters, repeats are not allowed. And there we go. There's our ways of selecting k objects from n options, where k is 3, n is 4, and just wanted to show a very concrete example where we could actually list them out, kind of see all the options. Right now, of course, in many cases where you want to use this, maybe you want a context where it's a very, very large number of options. You can't, maybe that's why you're trying to use these counting tricks, right? Because you can't just list them out. So let's think about another example. Suppose we have this. How many, again, let's go back to debit card pins. How many 4-digit debit card pins, right, can you select if no repeat numbers are allowed? Right, so maybe your bank has a rule that you're not allowed to just go 77777, right, for your pin, right? They don't want, and maybe they overdo it, and they don't just require that there has to be at least 2 distinct numbers in your pin, but they say no repeats at all, right? You can't even do 7417. Say you can't do that, right? The repeat 7, they say no, you have to pick 4 different numbers, right? So what would this do to the number of pins? Well, you could say this is what? This would be 10 permute 4, right? Why is this 10 permute 4? Well, because I'm going to pick k equals 4 numbers, right, from n equals 10 options, right? And where is that 10 coming from? It's the digits 0 through 9. Those are the 10 different digits we can pick, right? So what does this become? This is going to be 10 times 9 times 8 times 7. That's our formula up here, right? So you start at n, which is 10 in this case, and then you have exactly k factors, right? So I have 10 times 9 times 8 times 7 is exactly 4, k equal 4 factors, right? So that's what I'm seeing here. Or you could think of that 7 as 10 minus 4 plus 1, right? Is another way to think of it, as far as where you stop. Right? Or you can think of it as 10 factorial over 6 factorial, right? These are all perfectly good ways to think of this computation. And it would, just for sake of crunching out the number, what would we have here? We'd have 10 times, let's see, this is 90 times 56, right? So what do I get there? I get 90 times 50, what is 4,500? And 90 times 6 is right, is 540. So we get 5. There we go, 50, 40, right? So there is our product, right, of 10 times 9 times 8 times 7. So this is our just doing the arithmetic, right, for 4 numbers selected from 10. Okay. One thing to notice is once you get good at counting, a lot of probability questions become really easy, right? So suppose you had this. Suppose you said, a person picks a pin at random, right? They use sort of a 4-digit, standard 4-digit bank pin, right, at random. So they just pick one totally at random, right? Maybe they use a random number generator to just spit out 4 numbers in a row, right? Then you can ask, what is the probability that their pin uses no repeats? Right? So if you want to ask, what's the probability their pin uses no repeats? Well, what could you do? You could say, this is the number of pins without repeats, right, divided by the number of pins total, right? Okay, well, what's the number of pins without repeats? It's 10p4. What's the number of pins total? Number of pins total is 10 to the 4 by fundamental principle of counting, because now you're going to pick 10 options for the first digit, 10 options for the second digit, 10 options for the third, and 10 options for the fourth. Multiply all those together, right? So I'm going to get 50, 40 over 10,000, right? So it's kind of interesting. You actually get what when you do this division, right? I'm going to move my decimal place 1, 2, 3, 4 places, right? So I get 0.5040, right? Which is 50.4%, right? So kind of interesting. There's almost exactly a 50% chance. It's almost exactly equally likely if you just pick a 4-digit pin at random. It's almost exactly as likely of having 4 distinct digits as having a repeat digit, right? Which is maybe a little counterintuitive, right? You might think that the having a repeat is kind of special somehow, right? And that most of the time you're going to have 4 different digits, right? But the thing is, 10 isn't that large compared to 4, right? So it's actually in this case just about equally likely that you'll have a repeat as that you won't have a repeat. All right, there we go. So there's a definition of permutation, a theorem on permutations, right, of how to count them quickly, how to count the number of permutations. There's also then an example of 3 objects selected from 4 options, right? Then where we could kind of list them out, and I stopped short of entirely listing them out, but mostly list them out. And then one where it's way too big to list them out, but we can still count them, right? And you can still imagine this tree of 10 different digits for your first, right? You could pick 0, 1, 2 all the way to 9 for your first digit, and then you have 9 options for each of these, because for 0 you can now pick 1 through 9, right? For 1 you could pick 0 or 2 through 9, right? And so on, right? You can imagine this tree generating these 50, 40 options. So, and then here's a probability problem based on what we calculated above. So great. Permutations. Thanks. See you soon for our combinations.